Okay. Yeah. So what is the use of this index? You know very well, right? So in general scenarios, where we see this index, in every book it will be there. Okay. In every PDF document it will be there. So what is the use of this index? Okay. For example, let's take one book. Okay. I have a textbook. Okay. And that is having some 500 pages. Okay. 500 pages in it with different chapter names. So now I just want to open one particular topic, okay, or one particular chapter in that 500 pages book. So what I can do now, I have to search each and every page to find that particular topic because I don't know exactly where it is, right? So means what is going to be happen? Definitely it is going to take some time to find out that particular topic, right? So instead of that, just to avoid that, so what all people will do, they will give you an index about your textbook. If you see, there will be one page with the index, first page with the index. So what will be there in the index? So they will maintain all the topic names or chapter names along with the page number, so that now instead of searching each and every page to find out that particular chapter, so what you can do, you can just open that first page and see in the index for that particular chapter name. One second. Okay, for that particular chapter name and what is the page number for that. So directly you can jump into that particular page number. So means what is the use of now this index? It is simply improving your searching time. Easily you are navigating to now your particular chapters, right? The same thing in our database also. So there we are discussing about chapters and page numbers. Here also the same thing. Okay, here the textbook is our database. Okay, chapters are nothing but our tables and data. Okay, page numbers is simply is about data. Okay, chapters are nothing but your DB object, table and all. Okay, and in the table I want to open or check a particular thing, like a, so chapter is nothing but, sorry, textbook is nothing but my database. Okay, chapter is nothing but, there will be so many tables, right? So like that I am having so many chapters right here. So each chapter is nothing but one table for me now. Okay, so again page number. Okay, so that page number is nothing but data for me. Now we'll see one simple example here related to our thing. Let me draw one simple table to understand it easily. Give me a second. Yeah, now let me draw. Okay, so imagine I'm working with the empty table, okay, which is having all employees data along with their department numbers, Okay, so we'll just see what will happen before index and after creating index. Same thing how it was with the textbook, before index and after index. The same thing here also will happen. That's it. So before index, just see, for example, I have EMP table, right? So I'm just taking it as a EMP table. And imagine I have columns like this: employee number, employee name, okay, salary. So like this, I have some columns and followed by department number. Like this, I have many columns in that. Okay. Even after creating index, also same thing. I'm having same columns in my EMP table. This is my EMP table. Now, before creating index, imagine I inserted the data like this. First, I inserted a record. Okay. First, I inserted a record with the department number 10. Okay. So I've passed some data. Okay. I entered some data to other columns. Along with that, department number 10 I passed for the first record. Like that. Next record is 20. Next record is again 20 I passed. Next record is 10. 30. Okay, again 30, 20. So however you inserted the data, so the same way it will be, right? So I'm just telling 30 again, now 40, again 10, again 20, again 20, again 10, again 10. Okay, so like that, I inserted some 1 lakh records. I have now, just imagine, I have some 1 lakh records now in my table. Okay, just for example, I'm telling 1 lakh records. There may be 10 lakhs records also. There may be 50 lakhs records also. Okay, just for example, imagine my EMP table is now having 1 lakh records and the data is looking like this, department number wise. Okay, so now what I'm going to do, I'm just going to write a query like this. Select star from EMP table where department number is equal to 10. Okay, so what I written, select star from EMP where department number is equal to 10. That's it. So what it will do, first it will connect to the database and it will check for EMP table. And now in EMP table, I don't want complete data, right? So there is a filter. What is that filter condition? So I want to get only department number 10. Okay, so what I have to do now? I have to start searching to filter department number 10 only. So in our current example, so department number 10 is here. Okay, and it is next, no. Next, no. So like that, I have to do checking with every record till the last record. So I have 1 lakh records, for example, here. So means I have to search all 1 lakh records. Correct, right? Because I don't know where is this 10 exactly. So definitely I have to search each and every record. Where is 10? Where is 10? Like that. I have to check till the last record. Because even I don't know the last record is 10 or 20 department number. So we should search all these 1 lakh records one by one to get this 10th department data. So means definitely it will take some time. Same like our textbook example. If you don't have index in our textbook, definitely have to search each and every page to find out that particular topic. Same way here also, to find out this particular 10th department people data, we have to search each and every row till the last row. So definitely it will take some time. Right? So means that is nothing but called as performance not good. It's taking time. Okay. So what we'll do now, same like in a textbook case, I'm going to write an index. I'm going to write an index on EMP table, specifically with department number column. After index on EMP table of department number column. Okay, so I'm creating now index based on department number column, like in our textbook how we are creating based on a chapter. Okay, so chapter wise I created index in case of textbook. Now here I'm creating index based on department number wise, because I'm going to search based on department number now. So and also I'm going to search most of the times based on department number only. So I want to create index based on department number. If it is only for one time, I mean, I am just searching based on department number only today. Again, I will search it after 1 year. They're not required. Okay, but I'm going to search based on this department number most of the times regularly. So then definitely every time it is going to take time, right? So that's why what I'm going to do to avoid this, to increase this performance, what I'm going to do, creating an index on department number column. Okay, so after creating index, how your data will be looking? First 10th department. Okay, so then all 10th department people, okay, will be in one box. Then 20, all 20 records will be at one place. Then 30, all 30 will be another block. Okay, and 40 like in another block. So like that it will be organized properly. Same like our textbook. So like that till the last record, it is organized. You can just compare before index how the data is and now how it is. Okay, so after creating index, all the 10th department at one place. Okay, all 20, sorry, all 20 in another block. Okay, all 30 in another block. So same data, same thing. I'm not doing anything. But what is happening here? Just organizing the data properly now. Okay. So department wise, I organized the data now. Okay. So like that, it is organized. So what will happen now if the data is like this? So now when I'm searching for department number 10, okay, it will enter into the empty table. Okay. And then when I'm searching for department number 10, so it will directly use this index. Okay, how we are using index in textbook now? I'm going to particular chapter and what is the page number I'm checking. Directly now I'm jumping into that page number, the textbook. So it is saving my time. Same way here also, I want department number 10 only. So then I no need to search is all 1 lakh rows like before case. Okay, how I was searching before index, I was searching all the 1 lakh rows one by one. But now it's not required. There is an index. I will use that index. Okay, I'll use that index and I'll see where is this 10th department block. So this is 10th department, first yellow color one. So I'll take only that block. That's it. And I won't check these remaining things because it's already organized properly. So this is 10th department rack. Simply to say, so this is 10th department rack for me. So I'll take that rack data. That's it. Okay. So remaining, I don't want. I don't want to search also. Okay. So means imagine 10th department, for example, here in this memory, in this rack, in this block, I have some 1000 rows. Okay. So I'll take that 1000 rows. So still you have 99,000 rows in our current example. Means you no need to search that 99,000 rows, right? So definitely it is taking so much advantage. It's definitely improving, right? So much performance here, it is improving. Very less time it is taking for execution of that query. Understood, right? So what is the use of index? Is clear? It's very simple, but definitely we are going to use every time in real time, and there will be a question also in interview. Definitely. What is an index? What is an index now? Index is used to, index is a database object which used to improve the performance. Okay, so you should not say only this single line when someone asks you in an interview. So what you have to say? First, you have to say this line. Okay, it is used to improve the performance. But how it is improving the performance? Like this, somehow you have to explain. You have to take some another 2-3 minutes of time for this question to explain. Okay, so if you just answer it with one line, it will not take 10 seconds also. Okay, so what you have to do, you have to explain with any one example how it is going to improve the performance. That's it. Okay, now understood, right? So what is the use of index here? Anyone is having question? We don't have any question. We'll create one index now and we'll see how it is working. Okay, hope no one is having any question, right? Fine. So what we'll do, we'll create one index. Of course, we don't have long volume of data, huge volume of data. We don't have here. So definitely what will happen? It will not take much time. That's why we are getting the data every time fastly. We just have some 20 records also. No. So maximum 20 records also we don't have, right? So that's why it's not taking much time. But in case of real time, you will be having huge volume of data. Definitely it will take time. So that is the reason most of the times there will be an index for every table. Okay, so on which column, that is depends on which column it is required. Okay, which column and which column base we are searching most of the times. Okay, so on that column we'll create. Okay, fine. So now we thought like in this example, department number, right? So I'm going to search based on department number. Right? So now what I have to do? I have to create an index on empty table for this department number column. So then whatever, for example, if it was taking, okay, if it was taking some 10 minutes of time to get this data, after creating index, definitely it will take less time, less than 10 minutes. Okay, so what I'm going to do now, simply I'm going to create one index. To create any database object, there is only one command we already discussed. That is create index followed by index name. Okay, like create table name, create view name, create sequence name. So like that, here also you have to write any one name for your index because it is going to be stored into the database. Create index followed by any name you can give. For example, it's related to employee table, department number column. So I'm just writing emp underscore department number. You can write any name meaningfully. Create index name, done. On, okay, on which table? Emp table. Okay, emp table is done. Okay, on emp table, which column? That is department number column is done. That's it. Very simple, no? So I'm just going to create it and then we'll see how it is working. Please get connected. So I just copied that and pasting here and creating this index. And before that, if you want to check, is there any index on this EMP table? We already discussed in yesterday class, in last class, right? So what is that? All the indexes, whatever you created. So those will be stored in user indexes table if it is by user, DBA underscore indexes if it is by DBA. Otherwise, you can search in all underscore indexes. Otherwise, you can also search in all underscore objects, right? But what I'm going to do, I'm just searching in now all underscore indexes. Okay. Let me first execute this query and then we'll filter it for our table. Okay, it's coming. Now there is a index name you can see, and who is the owner, what is the index name, and like that there is a table owner. Okay, this is index owner and this is the table owner and table name, right? So now what I'm going to do, I'm just going to check for my table where lower of, why I'm writing lower of in, right? Table underscore name is equal to emp, right? Okay, it's not returning any data, means there is no index on this table. Okay, now we'll do, I'm executing this create index. Let's see, you can see this now message index created successfully. If you check this now in all underscore indexes, we'll see there is a record now for it. Index name is emp underscore dp department number, and owner of that index is this Varahi, and table owner is this, table name is this. Okay, and observe this uniqueness. Unique means, you know, right? Okay, there will be not duplicate. Okay, but it is non-unique, means you can write anything. If it is duplicate also, no problem, that's fine. But now, what is the use of this index which I created? This is useful only whenever you are searching based on department number column only. Okay, so for example, I'm writing select start from emp where department number is equal to 10. So then it is useful, as we discussed in this last example. It will be useful when you are searching with the department number 10, because it's created based on 10 department number. So the data will be, this is my raw data, it will be there as it is in the table. Okay, now after creating index, this is the first copy for me before creating index. After creating index, what will happen, there will be second copy, okay, with index. Now I have two copies of data. This is second copy for me after creating index, which is organized properly. For example, here it is organized properly on department number column. So this is useful only whenever you are searching based on department number only, because this is the heading for me, department number is the heading for me. So it is useful only when you are searching with department number only. For example, I'm searching now based on job, then it is useful now. Okay, here we can't see this performance definitely because we have less volume of data. But for example, now I'm searching based on a job. So then useful or not, select star from emp where job is equal to, for example, I'm writing manager. Executing is coming. Okay, but index is useful here when I'm searching with a job. Let's see, for example, 10th department, I'm searching for manager. In 10th department, he may be there or may not. In 20 also, manager may be there, may not be there. In 30 also same, 40 also same, 50 also same, right? So means in every department, there may be a job with manager, may not. So means definitely we have to search all the departments. Means we have to search all the records, all the 1 lakh rows we have to search for job is equal to manager. Okay, which means the index which you created on department number column will not be useful here. Okay, Clear, right? So when it is useful now, only when you are searching with the department number column. For example, now I want to improve the performance for this case also. Then what you have to do? You have to create one more index. Okay, you have to create one more index on EMP table with the job column. So then again the same raw data will be organized properly job wise now. Okay, so means one copy with the department wise and other copy with the job wise. Two new copies will be there. Okay, so there is nothing rule like so you have to create only one index on the table. Okay, you can create. Now what I'm going to do, I'm going to create one more index like this. Create index. Okay, index name, for example, I'm writing here EMP underscore department number underscore job. Okay, so I want to create this index on both columns. Let's see. On EMP table of two columns I'm writing now, department number and job. Index created successfully. So when this is useful, this is now useful only whenever you are searching based on department number and job. Okay, so now in my filter, definitely these two columns should be there. Then only this is useful. Okay, so means I'm writing now select star from EMP where department number first I have to find out, for example 10 or 20, and in 20 there are so many jobs. For example, I have 2000 rows in 10th department. Okay, and in the 10th department again there will be different jobs, right? Manager, analyst, testing, like this many jobs will be there. Again I have to search for that particular, right? So but I have index now. So what will happen in the 10th department? Again the data job wise will be organized. Okay, okay, what happened? It's coming 10th department and manager. So this index will be created like this only first. Okay, first it will be created like this, and again in the 10th department the data will be organized based on job again. Okay, so first job A, then second job B people, then job C people, job D people, like that again it will be organized. So means when I'm trying to search for department number 10 and job is manager, first it will enter into this 10th department. Okay, and 10th in 10th department also I have, for example, 10,000 rows. Then it is not required to search all the 10,000 rows for manager in the 10th department. Okay, because there is an index with the 10th department and job wise also inside. So directly it will jump into this, for example, manager, and whoever is there under that, it will pick. Okay, but this index is useful only whenever you are searching based on these two columns, because it is created based on department number plus job. Clear? Any confusion? Okay, now what we'll do, I'm just creating one more index. Create index, index name, for example, same EMP table, and I'm writing unique. And you can write any column. Okay, so for example, I'm writing here whatever the column you want to see without any duplicate data, for example, so that you can write. So as of now, I'll be not having duplicate, only an employee number, so I'm writing that. Creating it. Okay, created. This is normal index, okay, which we created as of now. I want to drop this index. Okay, otherwise I'll just show you. Let it be no problem. Okay, so I'm dropping this index using drop index name. Okay, index drop. So what I'm doing, same thing, same syntax, but additionally I'm using here a keyword unique. Okay, so means I'm creating unique index on this employee number column. Let's see now, created successfully. Okay, so what is the use of this now? For example, it will not same like a, let's see for where is this? I'm executing this all underscore indexes for EMP table. You can see we created these 3 indexes as of now on EMP table. And if you come here, this uniqueness is non-unique for the first 2 indexes, and for the last one, it is unique. Okay. You know what is meant by unique constraint. Same thing. Okay. For example, employee number, employees. And passing values like this here, employee number 101, I think I have. Otherwise, let me pass a different number 201 and the name is wrong. One row inserted. What happened? I'm trying to insert the same row again. One row inserted already. Okay, but I'm trying to insert one more row again with the same value 201. So it is throwing error. Unique constraint violated. Understood? But I have not created any constraint, right? So you know already what is unique constraint. We discussed in last classes. Okay, but right now I have not created this unique constraint on this column, but I created unique index on this column. Okay, so when you create unique index, so automatically constraint also will be there. But that is the meaning of unique, right? So it will have always unique data. Okay, understood, right? It will not allow duplicate data as it is having unique index. Fine. And it's like when you are searching, it will be helpful definitely. Okay, it will always make sure this column will have should have only unique data, and this will be helpful while searching also. Same like in other examples. Okay, all right. So now we created unique index also. Let's see to create one more index on characters kind of data like employee name. I am writing same create index, any index name you can write. Okay, emp underscore index on employee of ename column. Okay, if I create this index on employee name column, what will happen? So the data will be organized like employee name, right? And when I'm trying to search for a particular employee name, for example, something Ram, where employee name is equal to Ram, I'm searching. So what will happen? It will try to find where is a Ram, correct? But imagine I written name like this in my searching RAM. But you know already data is case sensitive, right? Data is case sensitive. It will be somehow in different case in database. Then again it will be a problem. So means you will get the data for sure, but it will take time, right? It will take time. So that's why what I'm going to do this time, I'm going to create index on employee name column but I'm using a function also here. So means I'm organizing my data. Okay. I'm organizing my data by converting that all employee names into lowercase. Understand, right? You know what's the use of this lower, upper, and cap. So what I'm doing now itself, before organizing the data itself, I'm converting the employee names data into lowercase, and then I'm organizing. Means nothing but I'm creating index after lower of e name. Let me create it. Index created successfully. So when it is useful, so whenever you are searching now, like this, select star from EMP table where e name is equal to. Okay. So then what you have to write? Again, if you write something else, it will not work. So what we have to do? So I'm writing lower of. I'm converting this employee's name data, but of course it is there already, right? Internally, in one copy of data, that entire data is organized lower of e name wise. Okay, but I should take advantage of that organized data, which is organized employee name wise in lowercase, right? So that's why I'm also searching now. Okay, somehow it just did get disconnected. No problem. Let's see. Okay, so that is the use of this index. Fine. Any confusion till here? No, right? And you know already how to drop this index also. Let me copy all this to here. Fine. So this is our index for one table. Okay. So for example, now I have a situation like I'm searching or I'm extracting the data now from two tables. Okay, from two tables I want to search, like by joining two tables, EMP table and DEP table, for example. So if you have index only on department table or you have only index on EMP table, that will be not useful, right? So that is helpful only when you are searching on that particular case. But now I want to join the two tables and then I have to get the data. Okay, so that reason what I have now, same like a index, I have a concept called cluster. This is like index only, but I am going to create it on multiple tables. Okay, index means on only one table. This is on multiple tables. For example, we'll create it on two tables, EMP and DEPT. How it is going to help, first we'll see. Let me draw same like index. We'll draw one table here first. Okay. Okay, just imagine this is my EMP table and this is my DEPT table. Separate two tables. Okay, there will be a concept called table space. We'll discuss later. Table space means space for all the tables. Okay, so just remember like that. So in that table space, I have two tables separately, EMP and DEPT. Okay, now so each will be having some columns, right? So what are those columns? For example, I'm just writing employee number, employee name, department number, salary. So like that, I have so many columns. Here also, I have so many columns like this: department number, department name. Okay, so like that, I have some columns. Okay, and now when I'm writing this query to get the data from these two tables like this, select from, give me a second. Okay, from, and I'm just writing here EMP table, alias name is E for it, and DEPT table, alias name is D for it. Okay, and I'm writing a join condition between these two like this: E dot department number is equal to D dot department number. Nothing but primary key and foreign key relation between these two tables I used. That's it. Now I'm writing all the column names here, whatever I want. From E dot end, I'm writing employee number. From E, again employee name. From D, for example, department number, and D name, department name. So this is my query. I'm extracting these four columns of information from EMP and DEPT tables, and I written a join condition or link between these two like this. So when I write this query, what will happen? It will go to EMP table and it will go to DEPT table. Okay, and then first it has to get the data based on this condition only, right? What is that condition? Employee table department number should be equal with one of department table department number, right? So for example, I have 1000 rows in my EMP table and some 10 rows in my department table, for example. So what will happen? Employee table first row, okay, department number is 10, for example. So what will happen? That employee table first row department number 10 record will be connected with all the rows of department table, and it will try to check with or try to match with where it is having 10 in DEPT table department number. Wherever it is matching, that value will come. We already discussed in the giants class, right? So like this, it will happen for all the rows, right? Understood, right? So what I'm telling, let me go back to here. Clear it. Select star from EMP. So this is my EMP table data. Okay, you can see here the first record is, for example, you can see this department number 20. When I write join condition like this, what will happen? Employee table department number, it will pick and it will try to match with department table department number. Now, for example, it is picking 20 here. Let's go to select star from DEPT. And I picked 20 from EMP table. And now here I have 4 records. First, I'll match with first record 20 is equal to 10 or not. No. 20 is equal to 20. Yes, I'll pick this. 20 equal 30. No. 20 equal 40. No. So like this, it will try to match each and every record from EMP table with all the records of DEPT table to match it, right? So definitely it will take time. If I have 1 lakh rows in my EMP table and some 10,000 rows in DEPT table, so what will happen? Each and every row from EMP table will match with the 10,000 rows of DEPT table. This process will be repeated for all the rows. Okay, so definitely it will take time. If you have index on EMP table and DEPT table also, it will not help now because it's a giant condition, right? So what I'm going to do now, Here also to improve the performance, for example, I'm going to create a cluster, kind of a index on two tables linking. So how it will be? For example, I'm just writing like this. Sorry. Okay. So before it was separate. EMP table is separate and DEPT table is separate, right? So now what I'm going to do after creating cluster, I'm creating a cluster, for example, now on this name EMP underscore DEPT cluster. Okay, and the giant condition actually I'm writing a department number column. So I'll use this department number column. So once I create this cluster and if I use it for these two tables, what will happen? So the entire data will be organized properly, department number wise. Okay, so how we will get the data after execution of this query? The same way it will be organized. Okay, so all this data, all the columns of data, whatever you have, will be organized properly here. Okay, so how it is organized means I'll show you. I'm executing this query. The data is like this. Okay, data is like this. The same way it will be organized in the database as a second copy. Okay, so what will happen when I'm trying to execute this query? You know already, it is going to search each and every record with all the records of this another table. Definitely it will be taking time. So instead of that, when you create a cluster based on department number column, it will already do this process for you. Okay, already that process will be happen and it will have a copy of data also ready for you. So when you are executing this query, that will come, that will use that cluster index and you'll get the data fastly, and it will eliminate that process what we were doing, searching one record with all the records of the EPT table. That process will not be there. So definitely time saving thing, right? So I will show you how to create this so that you can understand more easily how we are creating this cluster. Same like index only. I'm writing like this, create cluster followed by any name you can write, create cluster name. I'm creating this cluster on these two tables. So I'm writing EMP underscore DEPT. Okay. Underscore cluster. Some name, any unique name meaningfully. Please create cluster name. Now this is on which table? It's not related to any table. Okay. So I'm going to create it on a column first. So what is that column then? This is my column, department number. Okay. And also you have to write what is the data type of it. If you don't want to specify the size, that is fine. But if you want, you can specify the size also. Okay. For example, I given 2. We'll see what is the use of it. Okay. First, I'm creating cluster. Let's go here. You can see it says cluster created successfully. Now, when it is useful, now it is just created. You have to assign this cluster to your tables, which you want to regularly use by combining them or by joining them. In our case, we have EMP and DEPT table. I will be using these two tables to extract by joining them regularly. If you are writing this join condition or if you are extracting the data from these two tables rarely, then it's not required to create a cluster for it. But I'm writing this query regularly, I'm executing this regularly means definitely it is taking time every time, right? So that's why I'm creating a cluster on this column department number and I'm applying it to these two tables. Okay, so I'm just creating a new table here. Create table followed by any table name. Okay, let me take something like 21, EMP 21, and you can write all the column names, whatever you want. I'm writing here employee number followed by data type, employee name, varchar 2 size of 10. Okay, and one last column, department number is done. But here you should be careful. Okay, is nothing but I'm going to use the cluster, right? So when you are using this cluster, that clustered column, okay, what is that clustered column? Department number. That data is whatever is there, that should match it. Okay, so otherwise possible. Okay, so what I'm going to do, I'm going to keep it as a 10. For example, let's see what will happen. Department number is done. Now I'm applying cluster also for it. Cluster followed by cluster name. What is the cluster name? So this is my cluster name I'm applying. Okay, and then what is that column? Okay, I'm writing here the column name is department number. That's it. Now I'm creating it. Let me clean this. Okay, executing now. Okay, so we got some error. If you can see it, column definition incompatible with the clustered column definition. Understood? Column definition is incompatible with the clustered column definition. So means is clear. Column definition is nothing but department number in our case. This is incompatible with this clustered column definition. Same column name, same data type, same size. No, that is a problem. This should have same size also. Okay, so what I'm going to do now, I'm going to create it again by correcting that size as a 2. That's it. Now I'm creating, let me clear it. Now created successfully with clustered column. I'm creating another table also now. Create table. Same way, DEPT 21 for example. And I'm taking few columns here. Department number, you know already, but I'm not giving any size in this time. Let's see. Department name, varchar 2 size of 10. Now I'm applying cluster for it. Cluster followed by cluster name and the column name. I'm writing department number. Done. I'm trying to execute it. Same error. Okay, but I'm not giving any size now, but still it is throwing this error, right? Let's clear it. And I'm writing here size as 2. Okay, now I'm creating this cluster. Created. So now there is a cluster for these two tables. So what will happen when you are executing this query? Okay, so whenever you are executing this query, so whatever the process was happening, now that is not required. That will use this because this is already now organized the data based on this department number column, which is actually the link between these two. Okay, so now this is completely organized based on this. So when you are executing this query, automatically it will use that and it will get the data for you fastly when compared to before cases. That is the use of the cluster. Okay, any confusion about it? So if you want to drop this, then same like index only. Okay, so drop cluster followed by cluster name. Let me paste it. No, it is this cluster name. This is the name. Drop cluster name. Okay, so I'm trying to drop. Let's see what is the problem. Cluster is not empty. Now understood, right? Cluster is not empty means it is having some data. Clear? It is having some data. What is the data? EMP data, DEPT data, which is clubbed. Okay. So you know here EMP table is actually separate and DEPT is separate. When before index and cluster, when you created the cluster, both are combined like this. Okay, so all the columns, all the data from EMP and DEPT came into one place. Before I was using two places, for example, place one, place two. After creating cluster, only one place. All the data clubbed from EMP and DEPT based on that join condition. Nothing but that clustered column here, department number. Based on that, it is organized properly in one place only. That's it. So it will be useful now for us. And this cluster is now having some data. That's why we are unable to drop it. Okay, so then what you have to do? First, you have to drop that tables. Okay, so instead of that, what I can do, there is something like this, including tables. Okay, drop cluster name, including tables. Okay, it's done. Dropped successfully. If you try to find this table EMP21, we created it already, right? But if you try to see this DSC will write, okay, EMP21. I'm just trying to find this table is existed or not. You can see EMP21 does not exist. Okay, along with cluster, I also drop the tables also, whatever using that cluster. Okay, so wherever the tables are using the same cluster, all those tables got dropped. Clear? Any confusion till now? What is cluster and what is the use of it? When we have to use it and how to drop this cluster. Okay, so this cluster will be useful only when you are executing any query regularly. Okay, like I want to get this data from these two tables. So I'll write a giant condition definitely. And I'm executing this regularly, then only it is useful. If it is rarely means not required. Okay, so right. So any confusion or questions till now? No, right?